Yeah, there it is. Okay, it's over there. Oh, hi. Didn't see you there. My name's Chris Lau, and I'm a solutions architect at Red8.
I'm Tobias, and I'm a cloud architect at Red8. Time to talk tech!
So, Stephen, we were at KubeCon last year. The conference has more than doubled in size every year, it feels like. Why is everyone so excited about Kubernetes as a technology, and why should I be excited about it?
Yes, that's a great question. And there's a lot of buzz about Kubernetes. There's a lot of flashy products and flashy words. But I really like to kind of take a step back. Coming from an engineering perspective, why did we like Kubernetes or containers even to begin with? And one of those main components was immutability. If you think about the container, right, that's really the value here is the immutable container. You have a known state that you're deploying anywhere in your infrastructure. It's portable, it goes anywhere, and you know exactly what each container you know exactly what's in each container. And Kubernetes really helps you do that at scale. You have this great idea that is a container, you have this great concept that helps you as a sysadmin deploy applications, and Kubernetes helps you do that across any cloud, any provider, on-prem, wherever, kind of in a single layer.
So why, as a sysadmin, why do I like containers? Why would I prefer containers to my tried and trusted virtual machine?
So containers really, we've kind of been talking about infrastructure as code and these new kind of cloud native methodologies. Containers are a manifestation of that. You can't get a container without writing some level of infrastructure as code. It has to be codified and scripted out, and you end up with a known state. So containers are great because you have a known state and it can't change. It's immutable. So you can just, if something's going wrong with this container over here, you turn it off and redeploy, and you're back to being in the green. So really, it's just that stability and that portability that are great about containers.
So portability, that's interesting. So portability, is that deploying containers on-prem, the cloud, both? How does that all tie together?
It works the same everywhere. I mean, really, right? You get the same thing on my Mac as you do on Windows. If you have a container that conforms to the container runtime interface, it can be run on any machine. It's a specific type of, kind of deployment artifact that can run anywhere. So that's any cloud, any VM, developer workstation, and it's the same thing everywhere.
And is Kubernetes taking care of things like load balancing, perhaps auto-scaling, those types of things I'm used to from a hypervisor?
Yeah, so Kubernetes, at its core when it started, was really about a scheduler, right? So if you have 30 VMs out there, and these are all available for compute, 30 hosts, you might say, on your hypervisor, where is it appropriate to place this workload? Kubernetes will help manage that, and then it helps with higher level concepts like service discovery. Where do I send traffic? If my container is on host 1 but moves to host 3, how do I notify services of that? How do I still get traffic to it appropriately? So Kubernetes will manage placement of your containers. It'll manage service discovery. It'll auto heal if things go wrong. It's a kind of controller loop that helps manage your infrastructure.
I've heard Kubernetes and cloud native usually in the same sentence quite often, almost synonymous with each other. Can you explain to me what it means to be cloud native in this sense?
Sure. Really, when I think of cloud native, I think of when I first got into Amazon, right? And I remember coming from this on-prem world where we had certain servers that we had to keep online and things like that. Very static resources. One of the first things that surprised me in my AWS training was kind of the concept that anything can go away at any time, right? You have an SLA, and they say, we promise you we'll get somewhere close to this uptime, but if it goes down, we're not responsible. You got to handle that in your application code. And so that idea of promising an SLA, but the application itself has to manage things like HA and the architecture of the application. So designing for things like HA, designing for things like designing for things like auto healing, designing things for scalability. That type of kind of mentality is really what cloud native is all about.
And so it might not be as simple as me lifting and shifting my existing applications as they are today into Kubernetes. There's got it sounds like there must be a piece of work done on the back end on my application side.
Yeah, definitely. And that's like really to be kind of effective with a cloud native strategy, you have to adopt some of those principles. And sometimes that means pushing back on your developers or pushing back on other business units that maybe some application code has to change some to really see that, the promised land, what everybody says is so great about the cloud. Sometimes there's other work required, but really then you can start fully utilizing cloud resources and Kubernetes for kind of dynamic and highly available or scalable workloads.
So do I just go out there and buy Kubernetes? Like what are some of the platforms available that let me adopt this?
Yeah, sure. So Kubernetes itself, right, is as its vanilla upstream version is out there. It's open source. You can do it yourself. But everybody has what are called conforming Kubernetes distributions now. So this is things like Kubernetes services from Azure AKS, Amazon EKS, and Google GKE. But now you're seeing things like VMware's got TKG, the Tanzu Kubernetes grid. And you see, OpenShift is out there. And a lot of these vendors that we're probably familiar with in the space, like VMware or Red Hat, provide a lot of things packaged in that you might not get with vanilla Kubernetes.
Got it.
Does that answer it? I think.
Yeah, that does.
Okay.
Yeah, thanks.